Welcome to the ATRA webinar on the introduction to the 6L80. The 6L80 transmission that we're going to discuss today, we're going to give you an introduction on the operation as well as some of the basic diagnostic procedures that you'll follow with the 6L80. We'll then follow this up at a later date with a 6L80 diagnostic webinar to teach you about the intricate diagnostic processes you'll need to follow to do the 6L80 repairs. As we go through this, you'll have a button on your screen that you can ask a question. So if you have a question as we're going through it, simply hit the button and we'll ask whatever question or answer any type of question that you have about the subject itself. So again, if you got a question, feel free to ask it and I'll try to answer your question as we go. Okay. The 6L80 transmission, the first thing you need to know about it is it's the first of the GM 6-speeds that was introduced. It was introduced in the 2006 model year on the passenger car applications, followed by the SUV applications in 2007, and of course the truck applications in 2008. It is becoming the replacement, or is going to be the replacement for the 4L60E transmission, which is scheduled obviously to end production around 2014 timeframe. So the 4L60E production numbers are going down, 6L80 production numbers are going up. This transmission is currently being built in the Toledo transmission plant in Toledo, Ohio. It is a pretty large production run because obviously it's fitting not only passenger cars but also light-duty truck applications itself. ID of the 6L80 itself is done by looking at the RPO code. That's the simplest way to do it. As you can see at the top of your screen, it has RPO code MYC. So if this is a 6L90, it would be an MYD. If it's a 6L50 as an example, it would be an MYB. So the RPO code is referred to based off the label on a GM vehicle. It is basically nothing more than the Bible of how this vehicle is built. When a GM dealer orders a vehicle itself, he orders it based off these RPO codes. And so we use those RPO codes to ID exactly what type of transmission you actually have in your vehicle. The RPO codes themselves are in alphabetic and numeric order. So you simply go to the label. In this instance, this one is mounted obviously in the glove box. Some are in the center console. Some are in the spare tire cover area. But you're going to find this service parts ID label. That's called the RPO label itself. And that's how you're going to ID the transmission. The 6L80, as I told you earlier, was the replacement, or is going to be a replacement for the 4L60E transmission itself. Input torque capacities are very similar to the 4L60E, 440 or 430 foot-pounds of input torque capacity, 664 pounds of output torque capacity. Ratios quite a bit deeper than many of the other transmissions we've had in years past. As you can see here, first gear ratio, very deep 402 gear. Going up to 2 overdrives in 5th and 6th gear. So both 5th gear and 6th gear are overdriven. That's one of the reasons that this transmission was developed, is to try to improve fuel economy. Got about a 4 to 5% gain in fuel economy for the vehicles equipped with the 6L80. It goes up to the 8,600 pound GVW rating on the vehicle. So basically this transmission is up through a light 3/4 ton. If you get into a heavy 3/4 ton or a 1 ton, you're going to be moving into the 6L90 range. So for the passenger car applications, you're going to move from the 6L80 down to the 6L50 range. As you can see, we've got the standard prindle positions, park, reverse, neutral, drive, and some of the applications have a sport mode or a manual mode, so they have an S position or an M position. The electronics on the transmission are quite sophisticated. You're going to find that we've got 2 regular shift solenoids. Those shift solenoids are called shift solenoid 1 and shift solenoid 2. Those solenoids, guys, are primarily used to move the car forward or backward. They don't have anything to do with making the transmission actually shift. So if you've got a car that won't move one direction, you typically will have a failure with one of those 2 shift solenoids, because one is in charge of moving the car forward, one's in charge of moving the car backward. You've got 6 pulse width modulated solenoids, PCS 1, 2, 3, 4, 5, force torque converter clutch, and your regular line pressure control solenoid. Those solenoids not only control your pressures, but they also control which shifts you actually get. So to make the transmission shift, we simply cycle on or cycle off the appropriate solenoid. The controller for this transmission, like some other transmissions you're going to deal with, is mounted inside the transmission itself. Engineering calls it a TECM, Transmission Electrical Hydraulic Control Module, or TEHCM. It is a 32-bit processor mounted internally onto the valve body itself. It incorporates all the solenoids. It also incorporates some pressure switches and a fluid pressure temperature sensor. And that's all bolted right to the valve body assembly. The converters, we've got several different converters depending on application. So again, one size does not fit all on the converter application itself. Your converter will be matched to the particular vehicle itself. So not only is the stall-torque ratio matched, but also the K-factor of the converter is matched, obviously, to that vehicle. Fluid is required for this application. Is going to be Dextron 6. Now, most of you are aware that Dextron 6 came out about this time frame. The reason for it being developed was the introduction of these 6-speed transmissions. These 6 speeds do not turn the fluid over quite obviously like the 4 speeds did as far as flow through the coolers and so forth. And there's also quite a bit more clutch loading in these transmissions, so they felt they had to have a different transmission fluid, and that, of course, was Dextron 6. You see on your screen the capacities depending on which transmission you actually have. So bottom line is you're going to have different fluid capacities depending on what you actually have for a transmission. Clutch-to-clutch shift transmission, there are 5 multiple disc clutches and 1 sprag. What's that mean to us in simple terms? That means we've got to be very careful in making sure that we relearn the adapts in this transmission when we're all said and done with it. Because clutch-to-clutch shifts, as you all know, like on a 604, will get you in trouble if you do not relearn the adapts. Planetaries, you're going to have a couple planetaries. We got a simple Simpson-style planetary. In one end of the transmission, they have what they call a dual pinion. That's GM's name for it. It's actually a Lepeltier designed planetary, and the other end of the unit. Vane-style oil pump, pretty consistent with other transmissions that GM has had. Internally mounted TIS and TOS sensors. Both of those are Hall effect sensors. Internal mode switch. So we've got obviously no pressure switch like you're used to seeing on some of the other transmissions themselves. We do have pressure switches that are built inside the TECM. There's no external pressure switch on the valve body itself. Instead, they use an IMS like some of the later 4-speed transmissions have used. They have what they call performance algorithm shifting program itself that's designed for performance shift processes, and performance algorithm lift foot programming. So the whole idea here is if you're making a transition from full throttle to off the throttle, the transmission will not upshift on you. So don't be alarmed if you get a 6L80 concern from a customer where he cannot get the transmission to upshift by lifting off the gas. It's designed to do that. It's not broke. Don't try to fix it. Got a couple modes obviously available. We got manual mode. We have sport mode. Sport mode, like other GM transmissions, simply changes the shift points. Manual mode allows you to tap shift this transmission. So you're going to have a set of paddles on the shift lever itself that you can physically move on the shift lever, or you'll have a set of paddles mounted obviously on the steering wheel to allow you to upshift and downshift the transmission. This is a fully adaptable transmission itself, so it has fast learn capabilities. The transmission itself will have its own set of diagnostic codes. In fact, there is over 75 diagnostic codes simply for the transmission alone. So what's so different about the 6L80? Well, as you can see here on your screen, we have no accumulators, don't have shift valves. We got multifunction solenoids, which basically means they take place of these two guys up here. You're going to have some valves that the solenoids are going to control, but they're not called shift valves. You got backfill circuits and compensator circuits that are used to control your aggressiveness of your shift and your timing of your shift. We run an internal TCM, which we call the TECM, and of course it's a clutch-to-clutch shift transmission, unlike the 4-speed GM transmission. So why is DEX 6 required? Well, here's the reason engineering developed DEX 6. All of the 6 speeds require DEX 6. All your new 8 speeds coming out here in 2014 will also require DEX 6 as their fluid. Reduce sump volumes, higher fluid turnover rates. So they're cycling the oil through the transmission much quicker. Increased energy densities. In other words, bottom line is there's much more clutch loading in this transmission. Reduce cooling capacity. They try to reduce weight with the transmission applications. They've actually reduced the capacity of the cooling system itself. And of course, they got a clutch-to-clutch shift transmission. So again, you're going to have to make sure you got good quality fluid in the transmission itself. 50% improvement in film strength to reduce wear. What's that basically mean to us? It's a better quality fluid than what we had before. So Deck 6 itself will back service anything that's had Deck 3 in it. So if you had a 4L60E or you had a 4L80E that you wanted to put Deck 6 in, you could certainly do that. Here's an engineering chart, obviously on the differences between Deck 6 and Deck 3. You read the chart very simply by looking at the color codes, as you can see on your screen. This is my Deck 3 oils, as you can see here in red and also in the purple or the fuchsia color. As you can see, as we look at each different characteristic of the oil itself, the Deck 6 oil here in dark blue is much superior in each of those characteristics as compared to Deck 3. So Deck 6 has become the standard for the GM applications, and it's something you're going to definitely want to make sure you install when you're working on one of these units. Checking the fluid level. When it comes to checking the fluid level with this transmission, some of the applications like the trucks will actually have a dipstick. But a lot of the passenger cars, they don't physically have the room in the application for a dipstick. So what they will do is they'll actually put a plug in, and then they have what basically becomes a standpipe in the transmission oil pan itself. Now when you're dealing with one of these, it's very important that you make sure that you're at the right fluid temperature when you pull the plug out of the standpipe hole. If you do not do that, you're going to either have this transmission overfilled or underfilled. Now the fluid temperature that we're talking about, as you can see in the middle of the screen right here, is 86 to 122 degrees Fahrenheit. Now you can look at that fluid temperature itself via several, obviously, different approaches. You could use your scan tool on it. You could use onboard diagnostics on it, because most of them have a driver information center that will give you that information. Or you can simply roll underneath the transmission with a temp gun and shoot the pan with the temp gun. But the bottom line is, very similar to the Chrysler unit, you want to make sure that you have the correct temperature prior to trying to figure out what the oil level in the transmission is. If you do not, you're going to end up either overfilling or underfilling this unit, which is obviously going to be a detriment to the operation of the transmission. To do the fluid check itself, we made sure the temperature is correct, started the engine, pause at each gear range, as you can see, for approximately 3 seconds, put the transmission back in park, pull the level plug itself, and then we're going to simply look at the plug for the amount of seepage coming out of the plug. It should basically be dripping out of the plug hole. So this is the standpipe, so there's actually inside the pan, there's actually a raised area in the pan itself, so when the fluid is at the correct level, that oil will simply drip out of that level control plug where the standpipe is located at. If you had a lady uses a standpipe that's mounted in the oil pan itself, and again, the fluid temperature is very critical on this transmission, that you make certain that the temperature is where it's supposed to be prior to pulling the plug where the standpipe is located at. If you don't do that, you're either going to overfill or underfill this transmission itself. So the standpipe is located in the bottom of the oil pan itself, in this area here. It actually stands vertically in the area where the plug is at. So the idea basically is that the pan itself is going to have oil in the pan, and you have to raise the oil until it tips over the edge of the standpipe itself so that it can then drain out the end of the drain plug itself. So making sure that fluid temperature is correct becomes very crucial on this transmission. Clutches. The clutches in the 6L80 transmission itself are named after what they do, which has been a real plus for us. It makes it much easier to diagnose the transmission itself, because obviously a 4-5-6 clutch is only used in 4th, 5th, and 6th gear. A 2-6 clutch is only used in 2nd and 6th gear. So by knowing which clutch is on, you can obviously figure out what you're actually having problems with based off your symptom. So the clutches are laid out according to their name of what the function of the clutch actually is, which is a move definitely in the right direction. So instead of calling things obviously direct clutches and so forth, they don't do that anymore. It's basically named after what the function of the clutch actually is. So what's inside the 6L80 transmission? Well, what you're going to find, obviously, on the inside of this transmission is a lot of new gadgets that you may have never seen before, or you may have heard of them but never seen a picture of the thing since you've not had one of these apart. Or if you have had one of these apart, you've obviously become very acquainted with the products that are obviously in there. This brown device that we've got right here, this is actually the TECM. So this whole assembly right here, this is actually your TECM assembly. So the TECM consists of your solenoids. As you can see, we got solenoids here, 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 and so forth across the base of the TECM itself. The TCM, this is the TCM right in this area right here. And of course, along with that, you're going to have some pressure switches built into the base of the TECM, and along with that, you're going to also have some temperature sensors built into the TECM. There's actually 3 temp sensors in the TECM assembly itself. 2 are thermocouples that are mounted on the circuit board itself that are used for over-temp protection of the TECM. So if you exceed 142 degrees Celsius, which is obviously very hot, the TECM is designed to shut itself down for safety's sake. So the default in this transmission is either 3rd or 5th gear for limp home mode. And if you have an over-temp condition, a severe over-temp condition, it's going to default into 3rd or 5th gear for you. The regular temp sensor is used obviously to control your shift feel with the transmission itself. So just like we've used it before, it's strapped obviously to the external area of the TECM and used to control obviously the shift feel of the transmission itself. At the top of the screen, you can see the device we're calling the NISBU switch, or we're actually going to call that a IMS. The IMS, or internal mode switch's job, is to control obviously which gear range is selected. So this is your manual valve position sensor. In fact, it's actually hooked to the end of the manual valve right in this area right here. By having it hooked to the manual valve, we know exactly the position of the manual valve itself, so we can determine obviously which range is selected, so we know how many shifts you're supposed to have, as well as along with that, you're going to have the abilities to determine if you're manually downshifting the transmission or not. This is a look of the TECM itself rolled over on the other side. As you can see, we're laying out the different shift solids. We said the regular shift solid 1, and of course shift solid number 2 right here. Those are your on-off solids. Those solids control whether the car moves forward or the car moves backward. The other solids are all PWM solids. So these guys are all in charge of which shift you make and how aggressive that shift is going to be. Last but not least, you see right here in the middle, that is going to be your temperature sensor. So that temperature sensor's job is to tell us obviously how hot or how cold the transmission fluid is, so you can change the shift feel of the transmission. These little guys down here on the bottom, these are your pressure switches, and these are determining obviously your shift adapt. So we use this for shift timing purposes so we can update the shift adapt numbers. The shift solenoids that we use in the 6L80, you're going to, as we talked about earlier, have 2 on and off shift solenoids. They're a normally closed solenoid and they're ground side controlled. So what's that basically mean in simple terms? These are standard old B-flat, plain Jane style shift solids you've come to obviously know and love through the years. So you got 3 variable bleed solids that are considered normally low solenoids. This TECM is built by Bosch, and Bosch, of course, basically they refer to their solids as either a normally low or a normally high solenoid rather than a normally closed or normally open solenoid. So a normally low is used for a TCC, number 4 and number 5 solenoid. The normally high solenoid is your pressure control solenoid and your number 2 and your number 3 solenoid. So normally high solenoid is a solenoid when it's turned off, pressure is allowed to travel the clutch. So that's normally high. So normally low is just the opposite of that. When the solenoid is turned off, no pressure is allowed to travel to the clutch. So what does it boil down to? These solenoids are opposite of each other, just like a normally closed or normally open solenoid would be. The solenoids are high side controlled, so that basically means the computer controls the power going to the solenoid. They cycle these solenoids on and off at about 3,000 cycles per second. Now the reason for such a high cyclic rate, pretty simple. they're trying to prevent valve body wear. Talking with Bosch Engineering, I spent quite a bit of time with them on this product. They were really concerned with valve body wear, scrubbing actions of the valves, and they know that if they get the solenoid frequencies up, you don't have nearly as much valve body wear. So it's an attempt to limit the amount of wear in the transmission itself. Your VBS solenoids themselves, in other words, your PWM units, are a 5.5 ohm resistance at 70 degrees Fahrenheit, and their current limited is something less than about an amp. So 0.9 amps is where the controller shuts everything off at. If you do have a shorted solenoid, again, the controller will not be damaged because it is current limited. They do not send 12 volts to the solenoids. Just like everything else in this transmission, you're going to find out they run off a voltage-regulated 8.3 to 9.3 volts. The on and off solenoids are used strictly to control which direction the transmission moves. So we have one solenoid that controls it moving forward, one solenoid controls it moving backward. Your variable bleed solenoids, as you can see, control how aggressive the shift's going to be, as well as they control which shift you're going to get. So we turn on and off different solenoids to control which shift, and we control their duty cycle to control how aggressive the shift actually is. Your shift accumulation, since we don't have a bunch of accumulators in this transmission like we do other transmissions, is done electronically. And they also have something they call a compensator circuit that actually helps control your shift feel of the transmission itself. The solenoids do have a cleaning process. If you're running the transmission in park or neutral, they do go through a solenoid cleaning process every 30 seconds. They recycle the solenoids, and the whole idea behind that is to try to keep the solenoids clean. You will also have a cleaning process, as you're going to see a little bit later on, that will conduct with the use of a scan tool. The solenoids, as you can see in this particular picture here, this chart that I've given you, shows that they're going to be in the on-off state depending on what we're trying to do with the transmission. What I did with this chart, just so everybody's aware, when it makes a transition here in blue, that basically means that particular solenoid has moved positions or changed positions. So shift solenoid number 2, as you can see here, changed from an on to an off as I went to reverse. So this is the solenoid that's in charge of making the car move backward. Then obviously if I move into a forward range, it changes back into an on range again here. If I move back in the park range, it changes back into an on range. So what we're basically doing then is we're controlling this shift solenoid number 2, to control reverse range. So shift solenoid number 1 on the other side of the coin, as you can see, he is in the on position anytime we're in park, neutral, or first. Okay? When we go into regular overdrive range, we're going to move this shift solenoid into the off position itself. That will move the transmission into forward range so that we're ready to make the shifts. The rest of the transitions you're seeing on the right-hand side of the screen here have to do with obviously making that particular shift right here. So as an example here, this 1, 2, 3, 4 solenoid is in the on position, as you can see right here, anytime you're in first through fourth gear. If I move into fifth gear, we move into the off position right here. So as you can see on your chart, we're simply turning these solenoids on and off, but these particular solenoids over here on the right-hand side of the chart are on-off solenoids, where shift solenoid number 1 and number 2 are simply on-off solenoids. The other ones are PWM. There's going to be a plate on these transmissions. In fact, all the 6 speeds use this, that separates the TECM from the valve body assembly. It's very important that they keep, obviously, the TECM itself clean, and so they have what's known as a filter plate. The filter plate consists of a series of screens with basically rubber seals around the screens themselves. The filters that we're running are 170 micron filters, so they're a very fine filter, and the whole idea is to keep not only the solenoids clean, but obviously to keep the pressure switches clean in the transmission. Anytime you remove the TECM or valve body, it is required by GM to obviously replace the filter plate. They spend a bunch of time. I talked to several of the engineers that are working with the CERTA program, the Reman program, and they did a lot of testing on this, and basically what they did is they found out they had a huge failure rate if they did not replace the filter plate each time the valve body came off. So if you're going to be overhauling one of these transmissions, or you got the valve body or TECM they're going to be replacing, make sure you obviously replace the filter plate along with it. These are the pressure switches that you're going to protect. As you can see, the pressure switches are numbered 1, 3, 4, and 5. Number 2 pressure switch was dropped as it came out of pilot design into production. You're probably going to see these pressure switches go away here not too far in the distant future, like they have done obviously on the 6T40. The pressure switches do get contaminated, even though we got a filter plate on it. And they also have a delamination issue with the pressure switches themselves. So again, if you got a pressure switch code, which is a pretty common code on these units, take a look hard at the pressure switches for delamination issues. Good chance you're going to see one of them coming apart. As you can see, the switch number 1 is in charge of the 3-5 clutch, 3 is in charge of the 2-6 clutch, 4 is in charge of the 1-2-3-4 clutch, and 5 is in charge of the 4-5-6 low reverse clutch. The primary function of the pressure switch itself is to tell us when the clutch actually receives pressure. These are low pressure switches. So we know when, obviously, the oil pressure is coming out of the solenoid to go to the clutch assembly itself, and we're going to use that information to determine, obviously, shift adapts. The IMS on this transmission is your manual valve position sensor. So it basically hooks to the manual valve, and we control, obviously, what gear you selected based off the position of the IMS. As you can see, it's bolted strictly to the valve body assembly itself and has a little lip that goes over top of the manual valve. There will be a switch logic, just like there are for other IMSs, no different here. So each different range you select will determine, obviously, which gears, obviously, the transmission then allows to occur. As you can see here, the switches are high on the chart if they're at 12 volts. They're low on the chart, obviously, if they're at 0 volts. So this is a simple binary code switch. We've got 4 different signals coming off it, A, B, C, and your parity signal. And we simply look at when we change positions on these switches. So the sequence that the processor then sees tells us, obviously, which gear is selected. When we see a particular switch change positions, we know that the guy's making a transition from one gear range to another. That gives us the ability to anticipate the engagement. So my point is, you'll see some stuff in between the gear ranges. And pretty well every manufacturer does this. So if we moved here from reverse, obviously, to the position between reverse and neutral, you're going to see a gear change, or I should say a switch toggle here as we're making the transition into the neutral range. So the whole idea behind that is so that we can determine that you're actually moving the switch and which direction you're moving the switch to. So we know when the customer is moving the shift lever, and we know basically which direction he's moving it based on what this switch assembly does. Valve body diagnosis and TECM diagnosis. We're going to have a special tool that we're going to use, and it's going to require the use of a scan tool. Now, this tool itself is a J47821. That's the part number for the tool. That tool comes from Kent Moore. So if you were to dial up 1-800-GM-TOOLS, you'd get a hold of Kent Moore Tool, and you said, I want a J47821, they're going to send you what you're seeing here, obviously, in the screen. That is going to be this whole plate assembly here in blue with the pressure gauge hooked to it. You also get this harness right here. So that harness right there that I'm yellowing right now, that harness is in fact provided with the kit itself. So the whole idea behind this is for you to be able to take the valve body out of the car, I should say the TECM out of the car, and put the TECM on a bench and physically then hook some air pressure to this transmission TECM. And as you turn on and turn off the solids, you'll actually be able to see on the pressure gauges the TECM respond to that. If the pressure gauges respond, obviously according to what the chart says they're supposed to do, then you obviously have a good TECM. If they do not, you do not have a good TECM. So it's that easy to isolate whether you have a TECM issue or you do not. So as you can see here, what we're doing is we're actually hooking the harness from the vehicle to the TECM via this jumper harness that you can see attached in this picture. So this jumper harness attached to the TECM itself actually goes to the car, and then we hook the scan tool to the DLC, And we, in turn, then command the cell lines on and off with air pressure being obviously applied to the Tecum itself. And we simply watch the chart that is included in your handout itself to determine obviously what's happening with pressure. These are the ports that you're going to have, that you're going to be looking at. So pressure control cell line number 1 is off the G port, and on that blue block, you will find that the ports themselves are all lettered. And as you can see here, each different cell line has a different letter code. Just be aware, the little note at the bottom of the page talks about dither, which is a cleaning function, obviously, and it's going to happen even though you're testing the cell lines with the scan tool hooked up. So you got your scanner hooked up and you're watching the gauge, and all of a sudden the gauge moves on you. That's not a bad Tecum. That's just part of the programming it does for the cleaning process for the cell line block. So the whole idea behind this is to be able to bench test this solenoid assembly via this test plate. To test the other electronic component on the Tecum itself, it's going to require you to have a device called a signal generator. This is probably one of the handiest tools that you'll ever buy. This happens to be the Kentmore tool here. As you can see, it's a J38522. That's what I've got as a part number right here. But you don't necessarily have to buy the Kentmore one. You could buy anybody's that you want to buy. I just happen to own the Kentmore one, so that's what I use. We set it at 120 hertz. We set it at 50% duty cycle, and we're setting this thing at an 8-volt square wave. So as I flip it to the 8-volt square wave itself, 50% duty cycle, 120 hertz, when you have your scan tool hooked up via, obviously, the jumper harness, as you can see here, you should read somewhere between 100 and 400 RPMs on your scan tool. So as you change the frequency on the signal generator, you'll obviously see the frequency or the RPM change on the scanner. So what we're basically doing to check a speed sensor is we're substituting. We're substituting a signal generator in place of the speed sensor. If it reads correctly, you must have a bad speed sensor. If it does not read correctly, you must have a bad Tecum. That's how we isolate it. The 6L80 is equipped with full adaptive capabilities. Just like other clutch-to-clutch shift transmissions, you have to relearn the adapts themselves anytime any of these 5 things have actually been done on the transmission itself. So anytime we have done an internal repair that could affect shift quality, we've obviously recalibrated the TCM itself, so we put a new calibration in. We changed the valve body assembly or obviously the Tecum. So either of those, or we did an internal transmission repair that obviously could affect shift feel. Any of those things that you've done will require you to redo, obviously, a fast learn with this transmission. So let's say you bought a reman transmission that was not a GM. And so if it's not a GM, you're going to have to do a fast learn. The GMs are all fast learned at the plant. So that information is stored in the Tecum during the testing process of the transmission itself. But you got to rebuild from some other source. You're going to end up obviously having to go through and do the relearn itself. The relearn is actually fairly simple to do. Not a real razzle-dazzle thing. The first thing you need to know about it, you got to have obviously a compatible scan tool that's capable of doing obviously the fast learn. You're going to get the temperature up to where it needs to be. In this instance, we got to be somewhere between 158 and 230 degrees Fahrenheit. If we're between 158 and 230 degrees Fahrenheit, we then select the fast learn off the scan tool menu. You put it in drive with the car stationary, hit the button, it's going to be off to the races. You then put it in reverse with the car stationary, hit the button, you're off to the races. When you're done with it, it will tell you that the process is complete. You shut the engine off, obviously unpower your scanner, and you've done the fast learn. You're ready for your road test. Fast learn will not operate if, in fact, you have any of these different things that are obviously plaguing the transmission itself. So if you got some DTC set, if your temperature wasn't right, if your brake switch is not working because it requires you to have the brake on, okay? If TP was not at 0%, or the Prindle obviously switch was not obviously working, so your IMS is giving you troubles, or there's a line pressure control issue with this transmission. Any of those things will keep it from functioning. So it will say fast learn not complete on your scan tool. If it does say it's complete, then the fast learn is done. You're ready for the road test. Connector views of this transmission itself. We're going to give you the connector view. As you can see, what I want you to look at here is there's only a couple pins that you really got to be concerned with. First off, you got a battery power in here, and you got a ground in here. You got a CAN high, you got a CAN low. Nowhere in here do you see any examples of this transmission actually having shift solenoids controlled via this connector. So the days of obviously being able to hook into a circuit with a jumper wire and jumpering that terminal obviously to ground or to power or whatever it happens to be, those days are behind us. This thing is all done via the CAN data bus. So the bottom line is you've got to have a scan tool that's capable of reading the data bus and giving you the correct information. So information is going to become the king when it comes to these 6-speed and 8-speed GM transmissions that are coming down the road here. You can't do anything manually on this trans. So you can check power, you can check ground itself, but that's about as far as you're going to be able to go. Everything else can be scan tool generated. Pass-through connector, you got to be kind of careful when you unplug the pass-through connector. When you unplug it itself, it's going to be a snap lock. This is the snap lock right here. You physically got to snap that out before you can physically then pull the harness away from the Tecum. If you don't obviously unsnap it, you're going to end up breaking the harness trying to separate it from the Tecum. Well, that kind of completes us for today. What we'd like to do is we'd like to give you a little poll here. Well, I'll ask you a couple questions and see if you can answer our questions or not. So let's see if we can get the poll to come up. Okay. Should have popping up on your screen here any second. A poll basically says what type of fluid is required for the 6L80 transmission. Is it Dextron 3, Mercon 5, or Dextron 6? Okay. So your poll's been submitted, and we've got the results of the poll, and you are correct. It is Dextron 6 oil. So there's the results. 50% picked Dextron 3, obviously 50% picked Dextron 6. Correct answer, of course, is going to be Dextron 6. We got another poll for you, and it's how are the shift solenoids serviced in this transmission? You're going to see, obviously, popping up now, it says, how are the shift solenoids serviced? As a set, individually, as an assembly along with the Tecum itself. Okay, so I hit the close button, I hit the share button. Okay, in this instance, obviously, we are not correct. The correct answer is as an assembly with the Tecum. So again, thank you very much for attending the seminar, and we'll see you the next time.